Hello, everybody. Thank you for joining us today. I'm pretty pumped about this webinar today. We've got a great case study from one of our shared customers, and we're going to be talking about the integration between ClearEdge 3D Verity and BIMTrack. And so this should be a lot of fun, looking at kind of the entire workflow out on a job site, not just looking at one little bit or piece of it. So with that, let's talk about some housekeeping stuff. So first off, everybody's muted. So if you yell at us, curse at us, we won't hear. Second, if you've got questions, you can use the chat or the questions tool in GoToMeeting. We will take a pause towards the end to go through all the Q&A and answer as many questions as we can. We are recording the webinar, so if you have to pop out, spill a drink on your lap, something crazy happens, get called over by your boss, don't worry, you can come back and watch the rest of it later. We will shoot out a link within a week or two at the end of the recording, of the webinar with the recording. So with that agenda, you guys, I'm sure, can read. So short version, we're going to take a look at the case study and then talk a little bit about the technology behind it and then go into Q&A. And if we've got time, we will do a live demo at the end. We probably won't, but of course you can always reach out to any of us if you have questions. Yeah, so do a quick introduction. I'm not going to read through this list. I'm actually going to let everybody say hello. So first I want to start off with Jacob Dalbora. So Jacob, why don't you tell us a little bit about yourself?
Yeah, good afternoon, everyone. I'm the director of BIM services at McVeigh Mangum Engineering. So we basically look at buildings through the full life cycle, as built, construction, and then also operations. So this is one of our projects that we got to implement a tech stack on, and it was a lot of fun. So.
All righty, and we also have the wonderful Carl Viet from BIMTrack.
Great, thank you, Kelly. So my name is Carl Viet. I actually graduated in architecture in 2008, and I'm a design technology specialist and co-founder of BIM1 and BIMTrack. Also very much involved in non-profit organizations such as Building Smart Canada and CanBIM. And actually, I'm not a French person, but I'm a French speaker based in Quebec.
The French Canadians.
Yes.
And of course, there's me as well. Also a background in architecture, so definitely a common thread here amongst the three of us. And after many years in the industry, hopped over to ClearEdge, really to bring Verity to market initially, just a problem I was very passionate about. So yeah, with that, let's get into the meat and potatoes. So Jacob, why don't you take it away?
All right, thank you, Kelly. So what we'll do is we're going to kind of go through what the project was, a little bit of what we did at the beginning, some of the reasons why we implemented some of the tools, and then really kind of talk about BIMTrack and ClearEdge with the Verity and Rhythm side of it. So just starting off, it is an old JC Penney, so you did read that correctly. We actually, it's an anchor tenant for the Citadel Mall. It was gutted and renovated into an ambulatory surgery center. And it was a part of this revitalization of the area. They were trying to really build this area back up and thought ambulatory surgery center would be a great piece there, direct people to the mall, get them through. And at the end there, I put multiple unique scenarios. There's, just the thought of, unique scenario is in there being a JC Penney with ambulatory surgery center, but there's a lot of other ways that we made this very unique. Wanted to to kind of dive into what the project team was, and there's reason behind this that I'll kind of get into. MUSC is the owner, the ones that started this all. They did the whole, hey, we want to do IPD, and then it was, oh, but we want to do the IPD light. So it still had the basic structure, still had everything we needed, but we were completely open and trying to be as transparent as possible. So design side was McMillan, Patton, Smith. Engineers of record were ADC and BR+A. SHR I brought in there as medical equipment because they played a role within this as well. On the construction side, we had MBCon as the GC, MC Dean, Bell Constructors, Netta, and then Pasco were the subs. And my team was brought in under MBCon's side as the actual BIM coordinator, or BIM consultant to run all this. The reason I wanted to break down the project team was really, as much as we tried to push BIM and everything, these were the actual groups that ran, inside of Revit. So the design team did, but then only one sub was actually using Revit. So the other 3 subs actually had to come in and bring in BIM consultants. So we're adding a little bit more people into the mix. And then, as you can see in the bottom, fire protection is always great because they're usually in AutoCAD still. So now, as much as we are talking about a BIM project and everything, we have all these key players that are not necessarily in BIM, or they're leveraging other companies. And I have BIM 360 down here at the bottom because really it was all about trying to be on the cloud. The IPD light scenario, we actually had engineers of record and subs in the same exact Revit models building this all together. So this was literally a design assist, everybody together, kick it off and run with it. Looking at what we did now is, so we got this opportunity, we came in and we really had the opportunity to kind of implement as many tools as we could to help the process, to really see what we've been doing. So you can see it's broken down into 4 different categories. We got collaboration, automation, coordination, and then QA/QC. I think there was over 15 when we finally got done of different platforms that we integrated with or we ran with. It was, pretty extensive, and really, as I kind of give a little side caution here, this is not something that you want to do on a project, right? This was like a once in a lifetime opportunity. I gave it all. It was a lot of work, and it's a lot of work because, only a certain percentage of these platforms actually integrate with each other. So I was actually setting up how we were actually repopulating the same information from platform to platform just to leverage that tool. And when I say that, one of the unique things that we got though was, and we're going to talk about BIMTrack and Verity today, is the fact that they do integrate and they do, read the same information and then they can talk back and forth, where that doesn't make us have to repopulate everything just so one group can use BIMTrack and then another group could go into Verity. We're actually, leveraging it, going back and forth. So I touched on this before, the tech stack there. We were in the BIM 360 cloud. We were there, everybody was live, quote unquote, right? What we saw though was not everybody's, live. So you have a full project team and only the people that are live are the ones that are inside of Revit and the ones that, maybe can access stuff here and there when you publish. Well, that actually disregards quite a few of the other people that are participating in the project. And what you're looking at is people like fire protection, who is always in CAD. The project managers, so project managers for subs, for the GC, for even, engineers of record or the design side, or even MUSC. They're not opening up Revit to walk through the model and see what it is and what it's doing. Also, the people that are out there to do QA/QC the construction and QA/QC the documentation. So all of a sudden now we talk about all of us being collaborative, being on the same team. Really, the only people that are being collaborative are the BIM group, are the people inside the model, either doing, fabrication models or design models. They're the only ones kind of seeing everything live, talking back and forth. So how do we make sure we start leveraging tools to keep everybody on the same page, work through it? And what we did is we really brought in the idea of BIMTrack and Verity and how it was integrated to make sure that everybody was there to, have the same information in front of them. Everybody was able to participate and walk through it. So, much longer story. There's a lot of, we went through design, construction, and now we're about 35% of the way through construction now. There was a lot more to what we were doing, but what we're going to jump into is pretty much the coordination that we did. And as you can see, what's in the background there is your basic Excel file out of Navisworks of all the clashes that exist. And this one even shows you clashes that aren't even grouped. So you're now looking at thousands of clashes that have an XYZ coordinate, and that's how you have to go find them. This is such a pain, and people can't really read this, not to mention it doesn't mean anything to the project managers or anybody out there. So
I got to cut in. I remember working on a job a few years ago where I think we ended up with like 8,000 or 9,000 documented clashes. It was an insane number, and we had Excel spreadsheets. And I remember sitting in Navisworks doing screenshots for hours and copying and pasting them into a spreadsheet.
So I did the same thing.
Oh, I just look at that and I feel sick.
Yeah. Well, I've had the owner come to me too and be like, the GC just ran a clash and there is over 1,500 clashes. How does the design team mess up this much? There's 1,500. And we went through them. There was actually about 8 that actually mattered. So I love it when that first number pops up. They can say, oh my gosh, look how messed up it is. But
sorry, go keep going.
No, you're good, Kelly.
I saw that and I got that sinking pit of the stomach feeling. I was like, oh.
Headache all of a sudden, right?
Yeah. So getting into it, the reason I showed that is now going into issue tracking, creating those clashes and doing coordination. BIMTrack actually starts creating this workflow where you can do the coordination inside of Navisworks. You can publish it, you can see it in Revit, you can fix it, and then, start doing this circular model that you actually start fixing things correctly. You're not looking on it as, a spreadsheet that you're checking off or trying to do screenshots. But I keep going back to the fact that project managers, the fire protection, QA, QC guys, they're not inside of Revit. So even that workflow helps, maximize that. But what BIMTrack has actually pushed a lot for now is how do we include everybody, right? This is one of my main points about this tech stack was we have to include everybody. Everybody's a part of this project, and we can't just be the BIM guys inside of a collaborative atmosphere. So the fact that it is then published online, you're able to access it, view the model, view the stuff on there, it actually helps out so much to allow them to interact or allow them to go through it. So really, when we got this, we kind of had this idea that, with Navisworks, we're doing the coordination and BIMTrack doing, the issue tracking and being able to allow everyone. We got this idea, it's like issue tracking for everybody, right? You get issue tracking and you get issue tracking. And yes, I did do that during my my built lecture this year. So I wish I had a bigger room though. And it's key though, because you don't have just that PDF that is sent out to everybody or a Navis file that, you have to go one by one. Diving a little deeper into the actual workflow of the project. The building was split up into 8 different areas. It was based off of the phase schedule for construction. So you're looking at it upper level, lower level, area A, B, C, D. And then each of those areas, we ran a series of clashes that we actually established. So we had 15 different rule sets. As we go through here, you can see them all populating. So it was important to make sure we kind of looked at this and went through it. And I'm going to just touch on one thing real quick. This comes up. when you're doing this, make sure that you do have those rule sets and the naming conventions for them set immediately at the beginning. Because one thing we did find is other people do it for different areas, or if you got different groups going. If you have a mechanical pipe versus electrical clash detection, and then the next guy actually enters it as electrical versus mechanical pipe, those two don't integrate now. So once you start seeing BIMTrack and how you can leverage the filters and start seeing all the information, this now starts creating two different categories of types of clashes. And you really need to kind of pay attention to it, because you don't want to realize that you have 80 mechanical pipe versus electrical, and then 40 electrical versus mechanical pipe. But, you know, they might be the same clashes. They might be overlapping each other. And the same thing is the actual naming convention. So are you going to say mechanical pipe? Are you going to abbreviate it? There's a lot of different things that also start happening. So if you write out plumbing the full word, or you just do PLUM, it's a matter you have to establish that, because as you get down the road, as you get into the projects, you're going to populate a lot of issues and then realize that they're not coordinating with each other, they're not being filtered correctly, and you're starting to lose the leverage of BIMTrack. The next part, because of our ability to leverage basically one repository for everybody to see the clashes and issues, we did this thing called clash detection by mass responsibility assignments. And I hate that language because it actually sounds really, really lazy. So we actually now just call it coordination through collaboration, because we don't use the word collaboration enough, I think. So, you know, why not use it more? So what that means is we actually had distinct rules of where clashes and groups fell under were assigned to a distinct discipline. The reason we did this was we did not want to spend coordination meetings just trying to go one by one and seeing a pipe that goes across the clearance of a light 50 different times down a hallway, and somebody sitting there hitting down and seeing the next one. We've all been in those meetings. Those meetings are awful, and there's no reason for it. So the BIM coordinators back on the sub side, they're going to be going through issues already. So if it was something like a structural versus plumbing issue, it goes to the plumbing guys. If it was mechanical versus electrical issue, it goes to the electrical guys. What's really good about this is they can go through it, and if it's something that they find is not part of their scope, it shouldn't be changed on their end, they can actually reassign it to the other discipline, meaning that alerts them, they get it, they can review it, or they can flag it for us to actually review during the meeting. So now, instead of reviewing 150 clashes every week that are nonsense, we are actually going through 8 or 9 that really, you know, we have to talk about who's responsible for moving it, what are we going to do to change it, and how, you know, how's that going to kind of fall down the line of making everybody's responsibility is correct. And then, as I mentioned, this is J.C. Penney, so we had existing conditions to deal with, and going from a retail store to a ambulatory surgery center, there's quite a bit of you know, precision that was not needed for the first bit of construction, but now it is kind of needed for the second bit of construction. So we actually had the Leica RTC 360. We are able to kind of capture all the existing conditions when we gutted it all out. So basically everything was down to structure, a little bit of the piping coming down from the storm drains. But we actually were able to then take this stuff and we brought it into the Verity platform, right? So as right now we're basically 35% through construction, we are now starting to capture those construction milestones and compare it back to the coordination model. But when we were in design, what we did is we captured that as built, and we actually compared that to the design models that were being built off of as-built drawings. So now we actually have a, you know, degree of how far we're off. We actually found beams that were sloped inside of, or were sloped and shown on the drawing sloped, but when they were actually out in the field, they weren't. So those are things that we were able to pick up, and we were also able to understand the exact height we had within plenum spaces, understand where we were going. The other part of it was, this is the ambulatory surgery part, we started looking at it for floor flatness. So we were able to run the rhythm side of ClearEdge and see our floor flatness study across how it was working, and really areas that we actually needed to go back and look at. And as you can see on the right, we did the heat map and we kind of overlaid it onto our floor plan there and allowed us to kind of analyze it. That was just one piece from where it is, and that's why you can only see certain portions, but we are analyzing certain areas for certain reasons. So I'm gonna finish up here, and I got a couple tips and best practices, and then I'm gonna turn it over to Kelly. We will do questions at the end. So if you want to go ahead and type them in, you can, but we'll get to them in a little bit. But some of the things when doing this, and like I said at the beginning, this is not something that you should be full force going in on every project saying we need to implement this full tech stack. That's number one, is you have to understand the time that it's going to take to implement this. There's a lot of organization, there's a lot of time consuming, and just getting the information right. The second one is the more individual applications you integrate that don't integrate with each other, the more work you're going to have. So obviously Verity and BIMTrack work together. But if you are working with 6 different platforms and you have to publish to each one of them, and you have to gather the data out of each one of them and bring it back into BIM 360, that is just another set of workflows that you have to create and watch and manage. The other thing is make sure that the BIM coordination includes everyone, right? So this is where your project managers, your QA, QC, the fire protection, these guys that aren't inside of Revit, or inside of Navisworks, we got to make sure that the project teams are including everybody. It can't be this BIM group that does it and then comes back. So leveraging things like BIMTrack, allowing them to push it to, a web platform, be able to sort through it, see who's still responsible for his tasks is very key. Number 4, as you saw that full stack of platforms that we did implement, make sure that you implement and then train everybody, include everybody on the project team as much as possible. Don't say because that PM over there is not inside of Revit, he shouldn't have to learn this product either. We actually had a couple products where the PM came back to me about 3 months later and started showing me things that I never knew that product could do. So you'll be really surprised who takes hold of what areas, and then they just kind of start running with it. You got to give people the opportunity to do it. And the other thing, it's technology, right? You're going to have issues. You're going to have mistakes. So you really just got to acknowledge when those mistakes are. Because, even The Rock made the Tooth Fairy. Everybody makes mistakes, right? So on top of that, though, just don't repeat your mistakes. Let somebody else repeat your mistakes and you learn from them, right? So I'm sorry, Larry the Cable Guy, but it's The Rock. And on that note, Kelly Cohn now has to follow
The Rock.
Dwayne The Rock Johnson. Yeah.
Thanks for that.
Absolutely.
Yeah, and the one thing I wanted to chip in, because this is one of those things very early on for me that was a big learning experience, that concept of getting people that you might not think want to be involved, getting them involved is such a critical part to having a good project success. For me, it was always, I found like dragging the foreman into that review meeting in the, after you'd gone through kind of the clashes on your own and you'd figured out which things were actually real issues and, needed kind of a team resolution, making sure the foremen were in that room was so critical, because if they weren't there, when stuff actually hit the ground, they would just pretty much ignore the drawings in those spots anyway. And so then you'd end up literally with a clash that you had fixed, and you literally can see that they ended up putting it in the original routing because it was the most logical one for that particular sub, and they just completely ignored the fix. And it's like, so yeah, I thought that was a great tip.
but they've been doing it for 40 years, Kelly. So they know how. No, I'm kidding. But it's funny because you will find that the people that you don't think you should include end up becoming the biggest cheerleader for stuff. You know, some of those foremen out there, once they start seeing it, understanding it, they're like, holy cow, we need to do this on, you know, every project. And, you know, they really become cheerleaders for the stuff that we do. So.
Absolutely. Absolutely. So I do want to dive a little bit here into Verity, and then Carl afterwards is going to talk a little bit in detail about BIMTrack, just more from a technology standpoint. So as Jacob mentioned on this job, we're a little early for what Verity was really built to do originally, which is to deal with this kind of during construction QA/QC problem. But one of the things we loved about this project was, you know, Jacob and his team took this product and then applied it to a different problem, which was, hey, we have all these wonderful design drawings and models, and now we have a scan. Let's compare those two things together so we can see where the differences are, so that, you know, we can actually plan for these things prior to ever getting out in the field, and we can get better as-built models, even though the models have already been made. You know, just because the architect or the engineer has already made a model doesn't mean you're stuck with that as a basis for coordination after demo on a Reno project. You can go out there, scan, and get as-built versions of those to run through your coordination process. So really love that. And then in terms of the original kind of idea behind the product, you know, came from many people's experiences out on job sites dealing with this core issue of waste because of rework. And as we know, right now, the kind of regime out on job sites that, you know, most people deal with is a spot check. And actually, this is one of my pet peeves. Spot check is not actually what we do, because I think anybody that's been on a job site knows that actually what you check is the thing the superintendent is scared about. So you're not doing a random sample. You're not going out there and spot checking a true 5 to 10% subset of the work. If the superintendent is scared about the perimeter steel because they've got unitized glazing, that's what gets checked. You never check the interior steel because you just don't have time for it. And this is, I think, what's so exciting about some of the technology changes now, is that we really are starting to enter a universe where it's actually affordable to do a more robust QA/QC process. And that's because whether it's hardware or software, all the tools that kind of filter into this reality capture-based QA/QC ecosystem are much less expensive. You know, when I started scanning back at Beck about 10 years ago, you know, a cheap laser scanner was $130K. Now a cheap laser scanner is $20K. So just a dramatic reduction in price. Now you can still go buy a good laser scanner,
Kelly,
$120. Yeah, go ahead.
Really, how long did each scan take on those as well?
You know, it's funny. I remember a very similar job to this, Jacob, where we went into an old, it was actually a manufacturing facility that was above a retail space. And it was like a 100-year-old building where they literally made the products upstairs and then they sold them downstairs. And this was probably 300,000 square feet. And I remember scanning that with a Leica C10, and each scan took 45 minutes. and I think I was there for a week, and I think I did, gosh, I want to say in that week I probably did, you know, 60 scans, and man, I thought I was amazing. With an RTC, you can crank out 150 in a day, so it is a different world. So yeah, I mean, it's just all of these things are getting easier and easier to use, cheaper, and that means that the kind of technological limitations that made it, you know, basically impossible to check every element out on the job site or to check all of your as-built conditions, those things are mostly gone. We now have the tools to capture that information rapidly and efficiently, and then we have tools to kind of review that information as a first pass and present that information to you so that you can kind of quickly review it and then make have the human actually make an informed decision. So, that's really what Verity was designed to do, and it's pretty simple. You bring in the point cloud and the model into Navisworks, as that image that you showed illustrated, right? And then you run an analysis, and that analysis takes a informed first pass at figuring out whether things are installed in a passing way, so they are within a set tolerance, whether they're out of tolerance, or whether they're just not there, or if they're occluded because they're behind a wall or a piece of equipment or something that couldn't be validated. And so this gives you a really kind of robust understanding of both the status of work out on a job site in terms of schedule, but also in terms of installation tolerance. And then you go through and you look at it, because it is a computer algorithm. It's not perfect. There are conditions where maybe we don't have enough data to make a decision, but you might. There are conditions where you might have two identical things right next to each other. And our software is smart, but it's not as smart as anybody that's sitting on this webinar. And then you can review that. So, in this case, you've got something that's only 188 millimeters out, just a little bit. The little pink one here is where it was supposed to be. The cyan one is where it's actually installed based on the algorithm. And all of this information is then easily accessible, reviewable, sortable. You can group things. You can kind of do all of the different manipulations you'd expect to be able to do to kind of understand what's going on out on your job site. And then at that point, we're going to push that information out. So here's my obligatory Excel spreadsheet, Jacob. we can do spreadsheets, right? But of course, there's more shareable or more modern, I guess I should say. Everybody has Excel or some version of it. But we can push the stuff out to HTML, much bigger images. We can also export heat-mapped, colorized point clouds. So if there's only 30% of the beams that need to be updated in an as-built application, you can just dump out the point clouds for those 30 beams and send them to the engineer. Rather than sending them 10 gigs of point cloud files, you send them 15 megs. And then we work very closely within the Navisworks application, colorizing it, and pushing all of the properties in. So if you're a Navisworks guru, you can go wild with appearance profiles, have all sorts of fun. And then my favorite, we can actually as-built the Navis model. And so this is really useful for instance, what Jacob was doing, because even though the engineering model might have things sloped, we can actually translate and rotate the geometry into place in Navisworks so that you can run your clash against the flat object. You don't have to wait for a cycle and get a new model from an engineer. You can just immediately get to work on those as-built conditions. And then, of course, we can also publish these things to a number of web platforms. So we support Procore, which was also used on this project. We support BIM 360 Field, which was, I think, also used on this project. Or Jacob, were you using the new one or the old one? I'm testing him right now.
Sorry, I was on mute.
Yeah.
We're using the new one.
Awesome. And then, but we work with BIMTrack, and the beauty of that is BIMTrack has tons of integrations into other platforms. So that information that we can push up to BIMTrack, we get a nice robust web viewer of the entire model. We've got all the wonderful 3D issue tracking stuff, and then all of that information can flow out into applications like Revit and Tekla and blah, 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 and whatever, and AutoCAD and whatever the other people are using on the project, which I think is the huge advantage that we get with this integration with BIMTrack. So, and that, of course, is a wonderful segue for Mr. Carl.
All right, thanks, Kelly. All right, so now let's take a little step back and talk about how issues were solved and tracked on the project, right? So just a bit of background about BIMTrack, actually. There's a lot of model management solutions out there. BIMTrack is not one of them. So BIMTrack is about communication management. Lots of people these days are talking about collaboration, but good collaboration only happens if you've got an efficient process in place for communications to flow in the project, right? So everybody's aware of that challenge we're facing on every single project. I know lots of different stakeholders are being involved. You've got the architects, you've got the subs, you've got the GC. Sometimes you may have the owner also involved in some design review, right? And all of those stakeholders are working in different companies, and so lots of them have their own new tools for chatting with each other, but most of the information is exchanged through emails, right? That's how we collaborate with each other these days. Or taking the phone, giving a phone call to someone, and nothing's being recorded, and all of a sudden we're missing a deadline because issues were not solved on time. Many file types are being involved. There are different tools for a different type of stakeholder on the project. The steel manufacturers are working in Tekla. You've got the designers working in Revit, and so on, right? So many of the communications are actually prisoners of those models, and obviously that leads to an unmanageable amount of tasks in your mailbox. And so mailbox management, we've all been there, and you know how this works, right? Very hard to manage. And so looking at the current workflow, so everybody's doing BIM now, right? But this is what the traditional BIM coordination process looks like. So we've got on one side softwares for modeling, and those softwares could be AutoCAD based, Revit, ArchiCAD, whatever it is. And those models are then being sent, using FTP sites, servers, or more efficiently using BIM 360, right? So those models are then downloaded and analyzed in different pieces of software. One of those is Navisworks, and with the help of Verity, as-built variants and discrepancies with design intent model can be easily found, right? And then, most of the time, people will end up publishing cache reports, just like the ones we've seen earlier from Jacob and Kelly, right? And those reports are then being marked up by different stakeholders or being reviewed by, engineers and the lead designer and whoever's involved on the project in that type of coordination. And obviously, since those are file-based, coordination workflows, there needs to be some consolidations of the versions required before those things can be communicated to the design team for solving the issues in the original software, right? And not to mention that this process happens, dozens of times, and maybe hundreds of times on that project. And so there is a lot of time wasted in that process because everybody's working with things detached for the models. So reports and Excel spreadsheets, and people will waste a lot of time actually searching for the right view to solve the issue in the original software. And ultimately, this is a risk for missing deadlines because this process is not really efficient, right? And so this leads me to the next slide, actually. Yeah, so that's the communication chaos. This is where it happens. So we took that very seriously, and we look at how can we improve that communication chaos so that the information can flow, cross-platform, cross-software, no matter what model is being used, what version of it. So we kind of detach the communications from the model while keeping a geo-reference link to them so that they can be transposed over the newest versions of the design as things are moving forward. So you can always see this is what the issue looked like, and is this resolved in the latest version of the model, or is this resolved in the latest version of the documents, being PDF and construction drawings, right? So the improved communications workflow looks like this. So we've got BIMTrack fully integrated with about 15 different software applications. Some of them are CAD software, some of them are BIM softwares. And BIMTrack's not replacing or disrupting any model management workflow in place, but instead it's adding a layer of communication tracking in there. So you can clearly assign issues to people. You can create automatic reports to be sent to certain stakeholders on the project. You can actually schedule that every Friday. There's a report for pending issues assigned to the architect being sent out to them. So like when they enter the office at the morning, they see that PDF report in their mailbox. And they've got an easy access using the web-based viewer. So for those less tech-savvy users like project managers, or they can quickly log in there and access the issues, and just like a bit like a Facebook profile, they can open that issue, and they've got a news feed in there. They can start chatting and talking with people working in the BIM software. So all of a sudden, everybody's working on the same issue. So there's no more like parallel process. You've probably seen that on projects where you've got the project managers on one end, they're doing design review on PDF, and you've got the tech-savvy, BIM coordinators working in Navisworks, and they don't understand each other, right? So this is really what BIMTrack is all about, is unifying that workflow so that anybody can access, no matter what their skill sets look like. And so we've been talking about communications, right? But communications are not just about clashes. They can be errors, omissions, RFIs, requests, questions, data validation, site defects. Could be really anything you're exchanging as a screenshot in an email today. But the strength of BIMTrack is not just about taking static images like that. It's about creating that shortcut between different softwares. So if you're on the phone talking with one of the subs, and you're telling him, look at the issue number 15, and he clicks view in model, and instantly the camera is bringing you to the right location. And so this is really what we're providing, is that easy workflow for people to look at the same thing and transpose the issues in their software to see if it's solved in the current version of the design, the model actually. And so, as I said, BIMTrack is browser-based, but there's many integrations with existing software. So it's really not disrupting existing workflows. As I said, if you're working in Navisworks or working in Reddit, you continue doing your work with the BIMTrack add-on directly in those softwares. But in addition to that, for those who don't have access to BIM software licenses, they can just go online and turn on the models and start raising issues, viewing issues that were raised in other platforms in a very easy user interface, and also access, in addition to that, drawings. So those drawings can then be overlaid with the model, so you can compare as-built drawings with the model itself, and you can access issues on 2D or 3D, and you can actually also raise an issue in 2D and retrieve it in 3D in Navisworks. So those are some of the 2D to 3D smart conversion workflows that we've built to really unify the team. And this is something that has been quite useful for the different stakeholders on the projects to be able to centralize communications in one place. And that leads me to the question and answer session. So I'm sure you guys have tons of questions about that, super interesting technology stack in there. So it's now the right time to ask them in the chat.
Absolutely. So I will pull up the chat windows here, and I've also got the questions opened. So yeah, if you go to your little GoToMeeting sidebar, if you're the audience, you can pop open questions and you can start asking away. We do have a number already queued up, so just to start going through those. One of the first questions we had was, how did you align the scan with your models? So Jacob, how did you guys manage that on this job? And then I can probably pop in more broadly.
Yeah, we used a typical coordinate system that came from the site, The problem we had though, when we kind of got in there and saw it, all the structure out on site actually had fire protection on it. So we model, steel, and then we have fire protection that we can't really see the steel. So as much as we wanted to, do a full pass of how close we were, we basically had to use it as, all right, let's go through, see, we got the column system set up, we got it like aligned, and then we wanted to go through and see what was sloped, what was not sloped. If there were, 6 beams within a bay instead of 7, we were able to see those major issues and QA/QC it. Unfortunately, because of the fire protection, an inch and a half, I think it was, over the beams, we didn't have the ability to analyze how close it was. So Kelly can get into how to get that accurate point where you can do the analyzation, but ours was more or less, we knew what coordinates we had on site and we placed them within the models as well.
Well, a quick pro tip, Jacob, if you go into the Revit model, the structural families, you can actually put an additional sweep in that's with an offset. And so if you have a piece of geometry that models the 1.5 inch thick fireproofing on average, it actually works pretty well. So takes a few minutes to get into Revit and plug those in, but you can basically, set that on a fine level of detail so it doesn't show up in most drawings, or even, just, put a filter on it, make a new subcategory so that it only shows up in your Navis exports. But that's a great way to get to be able to use tools like Verity in cases where you have fire protection. You just have to know what the design thickness is of the fire protection. But yeah, there's a couple other ways, but fundamentally all of them involve some kind of a coordinate system, because what you don't want to do is basically visually align a point cloud to a model. You never, ever, ever want to do that if at all possible, because there's all sorts of gotchas. I mean, if you absolutely have to, because there's no other mechanism, you find the longest, straightest, flattest elements that you can, and you use those to set elevation, rotation, and then position. But in pretty much every case, you should at least try to get some coordinates out on the site you can measure. You figure out what those coordinates are in your model, and then you can go into the scanning software that's used for registering the scans together, and all of them, one way or another, support mechanisms to define custom user coordinate systems. And you basically need to find those points and replicate it. But that way you can load it into multiple applications and it'll always come into the same spot. So there's just all sorts of reasons to do it using defined coordinate systems. So awesome. All right. Perfect. All right, so we've got another one here, which is for Jacob. How were the contracts set up on this? I think this person may have missed the first slide on IPD Light, but how did they set this up in terms of an IPD Light project?
So they actually did a typical AIA prime contract between the architect and the GC, but they amended them with a lot of language from an IPD contract. So they were required to, participate in both design and construction. Everybody was in the same models, but once again, it was your hierarchy of prime contracts and subprimes that made it, IPD Light.
Awesome. And then actually, I think I'm going to turn over the screen here to Carl, make you presenter. One of the questions that came in was basically, how can you show that workflow of kind of finding an issue and then uploading that issue to BIMTrack, just to help better understand how that process is managed?
Yep. So in terms of, I believe you guys see my screen right now.
Can indeed.
All right. So just to answer the question, this is what the BIMTrack add-in looks like within the Navisworks environment. So we've got different ways to transfer issues from Navisworks to the cloud and then retrieve them in other softwares. We've got the clash to issue feature, which was used on the project here to batch transfer different clash tests. We've got save views to issues, and we've got different options in here to just raise issues on the fly as you navigate the model and do some constructability reviews or design review. And so the strength of BIMTrack, as I said, is this ability to view and model like that in one software, jump to another software, and click view and model, and that's going to bring you to the exact same location than Navisworks. So you can see that this process is quite easy and live. So raising an issue is as simple as locating the issue in the model, click create issue. That takes a smart screenshot, georeference location like that, and say change beam sizes here. And then you can actually mark up using the markup feature, and then assign that to someone. They receive email notification, set due dates, publish that, go in Navisworks, refresh the list here, and that issue is going to be pulled from the cloud, and then you can actually see that in the model now, just like that. So in terms of efficiency, that's very hard to be faster than that. And those are also displayed as clashes in the model like that. So you can actually isolate those clashes as you start reviewing them. So you could say, I want to see issue 787 like that, apply, and then very quickly view and model that issue, and or select it and create a section box around it to isolate the issue location like that. And this is what the clash looks like, right? So this is pretty much how the the BIMTrack add-in was used here to publish clashes from the clash test on the project to Revit, and then quickly find those issues in both software. So just like that, 787, apply. This is the clash location, view and model. And then that's going to generate a sphere in 3D in the model to locate the issue, and you can actually create a section box around it to see it in 3D.
And I want to add an asterisk in there. We pulled some old models for this presentation, so that is not currently happening in the field, that clash.
Yeah,
good caveat.
I modified the status here, Jacob. It's now open, but
all my credibility just went out the window because
yeah, I kind of tricked you with we're rolling back in time.
All righty. Now that's a great demo. Yeah, and then let's see here. Another question that we had was what all kind of elements were you able to run Verity on when you were comparing the design model to the point cloud, or what things were you looking for when you were making that comparison?
Well, the design models were basically the only thing that was there was structure. So that's what we took and we put in there. We ran it basically for almost a size comparison, kind of make sure that there wasn't a deeper beam somewhere that we didn't recognize before. But once again, without knowing Kelly's trick about the fireproofing, we actually couldn't run a full analysis. We kind of went in and saw, all right, they give you tolerances, right? And you say your red comes out of tolerance. So we actually went to a more of, hey, we're going to give a really big tolerance, and then the things that actually fall really far out of there, we need to go look at, because that means that it is off from that 1.5 inches that we were supposed to be in. And that's where we kind of went back. But once again, it wasn't ever the precise, but it was just structure. We had exterior walls for architectural, but that wasn't really necessary at that point.
Yep, understood. Yeah, and just to kind of give people an idea of some of the things this can look like, this is a different project, unfortunately, because you guys aren't quite far enough along on that one to show it. But This will kind of show you the information that you can get out of Verity in these cases, looking at structure. Again, when you've got fireproofing, you can either use that trick, or if you just want to do a quick comparison, this is probably what you guys did. You can visually look and get a feel for it. We also have that problem quite a lot with things like duct, for instance, where the sheet metal gets modeled and the scan's done after installation, and you kind of have to come in and just visually look and see if you think that ductwork is in the right spot just based on the data that you have on it. So yeah, if you can't get a hold of the model and get some insulation in there, then you kind of have to do a visual inspection. But if you can get insulation, this is pipe insulation. We're not actually looking at the real pipe here. But even without a ton of data, we're able to quite accurately find and locate where that pipe is actually installed, and then yeah, give you all sorts of wonderful information about the discrepancy between the two different models. So, all right. Let's see, I'll repeat this. Somebody just came in late and asked about the recording, and yes, the answer is the webinar is being recorded and we will post it. So give us about a week or two, and then links will go out to download that. Let's see, any other good questions here that we ought to get in the last 2 minutes? Let's see, I don't think any of those are short answers. So we'll, if we didn't get your question answered, there's quite a few. We will follow up with you afterwards as best we can. We'll kind of dole these out to the three of us, and we'll see if we can get you answers offline. But outside of that, I think we are gonna call it a day and wrap up. For my part, thank you guys so much for sitting in and listening and watching. Carl, Jacob, well, I'll let Jacob go first. Any last thoughts, Jacob?
No, I'm just, one of my big points that I harp on quite a bit is you got to involve the whole project team. We can't be a siloed BIM coordination and not really be involving everybody. But if you guys do have questions, we're all on Twitter quite often and on LinkedIn. Don't hesitate to reach out.
Yeah.
Thank you, everyone.
All righty. Thank you all so much. And yeah, have a wonderful rest of your day. And yeah, look for us at conferences and on Twitter and LinkedIn and wonderful online forums like that. So bye-bye.
Thank you.
Thank you, bye.